Figure 3.1 shows an oil tank that has a rectangular base of dimensions 2.4 meter by 1.5 meter. The tank is filled with oil of density 850 kilogram per meter cubed to a depth of 1.5 meter. Calculate the pressure exerted by the oil on the base of the tank. So let's start off by the formula, which is pressure equals density times gravity. Since oil is a liquid, we're gonna use the pressure in liquids formula, which is pressure times which is density times gravity times height. Now let's use the values, which are density equals 850, gravity equals 10, and height equals 1.5. Since they are all in SI units, we don't need to do any conversions. Now let's multiply them to get the final answer, which is 12,750. We can just write it as 13,000 pascals in two significant figures. So now to find the force exerted by the oil on the base of the tank, we're gonna use the formula of pressure in objects, which is pressure equals force divided by area. Since we want the force, we need to rearrange the formula, making it force equals pressure times area. To find the area, we know that the dimension of the base, the dimensions are 2.4 by 1.5, so we're gonna multiply 2.4 times 1 times 1.5, which gives us 3.6 meters. Now, to get the final answer, we need to get the pressure, which you already have, but this is a rounded one, so we're gonna use the original value, which is 12,750 times 3.6, which is gonna give us 45,900 newtons. So we can actually round it to two significant figures too, making it 4,600 46,000 newtons as our final answer. Moving on to the next question. The force calculated in A3. Let's go check what is A3. This one, which is 46,000 newtons, is the weight. So there are actually two ways to do this question to calculate the mass of oil in the tank. We can either use it this way, which is weight equals to mass times gravity, or we can use the density formula, which is density equals mass divided by volume. Find the volume, we're gonna rearrange it, making it volume equals, to find the mass, we're gonna rearrange it. We're gonna rearrange, which is making it density times volume. So we know that the density is 850 and the volume can be found by multiplying 2.4 times 1.5 times, so 2.4 times 1.5 times 1.5, giving us a volume of 5.4, which we can then multiply with the density, which is 850, and we will be getting the same answer, which is 4,590, but we can actually also use the final value over here in force, and hence we're or we can just like round it up. So to round it up, we're gonna get the same, which is 4,600 kilograms. So when he is checking the level of oil in the tank, a man drops a brass key into the oil and it sinks to the bottom of the oil. State what this shows about the density of brass. This clearly shows that brass has a greater or higher density than oil, hence it sinks. Explain how attaching the key to a piece of wood would prevent the key from sinking. Since wood is less dense or has a lower density than oil, it would float. And then if we attach a brass key, the brass key, which obviously has a higher density or a greater density, since it's attached to the piece of wood, it will keep the key, or the key will be afloat. The brass key will float similar to the wood.